Our next speaker, we have Kamalika Majumder, founder and director, Cloud Kata, Statsa LLP. She helps customers in various domains like banking and financials, insurance, e-commerce, retail achieve continuous delivery of quality products and services. She also helps organizations transform traditional IT to a DevOps-driven lifecycle by forming cross-functional, poly-skilled teams. Her topic for today is Always on Digital Books on Modern Infra.
Hello everyone, my name is Kamalika Majumder and I am an independent consultant for DevOps and modern infrastructure. I've been in this space for quite some time, and in the last 4 years, I have been working a lot with banks and financial services in enabling digital transformation in their organization by enabling DevOps and continuous delivery practices. And in this session, I'm going to talk about this first-hand experience of this journey and share about always on banks and their impact on modern infrastructure. So let's get started. I'm going to share about a story of two digital banks and what is shaping the digital transformation in banks and financial services, and how modern infrastructure is empowering this digital transformation. These are two banks, although they are two very different banks, but they had one single goal, which was always on digital banking services. They were up and running 24/7, and their customers would perform various banking services throughout the day. So they had very least chances of going down or even having a maintenance window. And even if they had a maintenance, they had to announce it, and it has to be a pre-planned maintenance. So what was different about these two banks? One of them had data on-premise, or more like a traditional bank, which is located on a proper on-premise data center. And the other had data on cloud, which had no data centers, and all of its infrastructure was located on cloud. So although they both are banks and both were headed towards digital transformation with mobile applications, but structurally they were different on where they were hosting their data. So the requirement or the necessities to build these two banks were very similar. They had to comply with security and the regulations of the governance. They had to have always on services because they wanted to give a 99.99% SLA, which in an average means around 4 hours of downtime yearly and 10 to 15 minutes of data loss, which technically means that they can afford no downtime at all. So that is why they are called always on banks. And they had 100% digital services. Although one of them had data on premise, but they did not have any branch where they would perform manual services. Everything was driven via their mobile application. So all their services were 100% digital. Because they were running always on banking services, they need to provide a very performant and quality driven applications. And these are mobile applications that we are talking about. So their mobile app have to be very performant, very snappy, because if that does not work, they will be losing potential customers. And of course, since they were onboarding a lot of customers and the onboarding was super fast because of the digitalization, they had to take care of scale up on demand. So they could not, they didn't have any window to plan and then scale. They had to be prepared to meet the scale which was coming into their way. So they had to have scalability in their infrastructure so that whenever there is a peak hour traffic or load, their infrastructure will automatically scale out and give the performance that it has to give to their services. So these were the top 5 business requirements for both these banks, one of whose data was on premise and another was on cloud. So now let's look at what were some of the challenges that I faced while I was building modern infrastructure for these two banks, and what were the solutions that was implemented for them. So let's first talk about the bank on-premise and how modern day infrastructure helped them in their digital transformation. So some of the common challenges that I faced, and I think this is common for any bank that we see, or most of the banks, is legacy systems. As we all know, banks were in existence much before modern infrastructure or DevOps concept came into place. So they have a lot of legacy system infrastructure driven via bare metals and a bare metal focused hypervisor. And that is why there was lack of automation, because these systems were being set up manually. And when this system were in existence, we did not have those tools or the ways to automate. So that is why there was a lot of lack of automation in that bank, and that imposed scalability issues. So it was not very easy to scale out. Suppose they had to onboard 1 lakh customers, so they had to prepare for that well in advance, and sometimes they had to do an annual budget preparation for their infrastructure. They had to purchase the infrastructure well in advance, because these were all hosted on premise with legacy system with bare metals. So due to the legacy system, there were lack of automation, and that in turn posed difficulty in scalability. And that by design gave rise to monolithic data systems. Most banks, I believe, have a monolithic system, and to transform them into a modular architecture is very difficult, especially for the data services. Many banks still use the older data services systems, the SQL systems. So it was also difficult to manage these data services and to scale out when there is a heavy data upload or download. So because of these challenges, it was also difficult to build a very highly available service or to account for disaster recovery, because there was not much room for automation. That is why we had to follow some old traditional method to get high availability and disaster recovery. And last but not the least was team silos. As we all know, these are in banks, we hardly see agile practices in place. Agile came much after the banking system or banking setup was there. So they inherited a lot of silos in their organization, and to convince them to onboard into agile way of development, agile way of engineering was very difficult. So there was a lot of silos, and there was a lot of disconnects among the teams, from the software developers to the infrastructure administrator. So it was always difficult to communicate or to build an end-to-end automated system. So what did we do to mitigate these challenges, and what were the solutions that were implemented for these banks? As I mentioned in the beginning, these were always on banks. So we built a always on platform as a service. Now, some of you might have a question, why platform as a service? Why not infrastructure as a service? Now, since they had a lot of legacy system and a lot of bare metal based infrastructure, so it was very difficult to replace them overnight. So what we could do is utilize as much as possible on the existing infrastructure and build a platform as a service on top of it, so that at least for all their services that they're building on a mobile application, we could provide them a seamless platform to develop, to test, and to take it live. The next thing that we implemented were templatized and automated build and deployment method. So if you look at a bank, they have a lot of functions that goes into play, right from customer registration to transaction to maintaining transaction histories to doing fund transfer within the banks, across the bank. So for each of these services, there would be a software or application running in the behind. So we built an automated system for build and deployment, and it was driven via a template. Let's say they are building microservices and all their backend services were built on Node.js. So we build a build template which could develop, which could compile and deploy all Node.js application. Let's say they have a combination of Node.js and Java application. So we build a template for Java for compiling and deploying that service. So this bank in particular had both. They had a microservice-based mobile app, which was written in Node.js, and they had a traditional system which was written in Java. So we wrote a template which could on demand create the design or the CI/CD pipeline for build and deployment for both Node.js and the Java services. The third thing that we did was centralized configuration management. So in order to break the silos between the teams, we build a centralized configuration management design. So, and a continuous delivery model, so that everybody is driven via the same design and practices, and they would not deviate from each other. And this helped us in making sure that all the good practices were in place across the teams. As I mentioned, there was a lot of team silos and coordination issues. So we had to begin with a centralized process-driven mechanism, so that we can give them a design that all can follow, no matter if they're working in different teams, but they can still follow the same design and same configuration management system. The fourth thing that we had to implement, and this was part of the always on design, is zero downtime deployment. Now, this was very interesting because zero downtime deployment for legacy banking system is very challenging. What we had to make sure that no matter what kind of activity we do, be it on infrastructure or on software delivery, there would be minimum downtime. As I mentioned, that we were heading towards 99.99% uptime. That means on an average, we can only afford around 4 hours of downtime, and that too, it has to be a scheduled downtime. There were no window or no chance of the system going down, because if a bank goes down, then that means a lot of money will be lost. So that is why we had designed a not just a blue-green or an automated deployment, but it was a zero downtime deployment. And how did we do that? So we did that using environment on demand. So when we were building this always on PaaS, we made sure that all the systems are automated on virtualized mechanism. So we used the microservices way of software development. So for every microservice, we had a virtual environment where they could test, they could run all kind of functional and integration tests, and then they can promote that to production. So from dev to prod, the logical design was always same for the environment. It was only the virtual environment that was segregated. So, and these environments were always provisioned on demand as and when they are needed. So that gave us a capability of achieving zero downtime, even when we were doing kind of cluster upgrades, let's say. So when we had to do, let's take, for example, if we have a Kubernetes cluster and we want to really attain zero downtime deployment for upgradation of the whole cluster, what would we do? So we built multi-DC model, and we had the way of blue-green deployment in the backend, wherein all the microservices will be evacuated on the blue cluster, while the green cluster was getting upgraded. So with that approach, we could attain a zero downtime deployment model for the microservices. So here, the zero downtime is for the application and services which was facing the customers. Whereas in the backend, there was a downtime, but the impact on the end user was close to zero or no impact at all. And multi-DC stretch cluster was another thing that helped in achieving these zero downtime deployment. Because it was a bank on premise, we had to account for a DC and a DR model. So they had one data center where the primary traffic would be directed, and then they had the secondary data center. So we did not treat them as the primary or secondary. Instead, we built the platform across both the data centers so that the traffic will be received on both. Let's say one of the data center was down, then the traffic will be shifted to the other data center, and likewise. And it was also helpful when we were doing any kind of infrastructure upgrades, which is like scheduled maintenance. So our maintenance window, during the maintenance window, the traffic will be shifted to the other data centers so that the customers will have very minimal impact, and we could do all our upgrades without losing any data or any customer. So multi-DC stretch cluster was another key approach behind building this always on pass. And in order to mitigate the silos that existed in the teams, we followed agile DevOps. Now, what is agile DevOps? So that means what I mean by agile DevOps is following the agile practices while implementing the DevOps best practices. That means if there is a group of people who are automating infrastructure, they need to follow all the practices of agile that they would have followed when they are building a software development. So we called it infrastructure development, and we followed all the best practices of agile, like the sprint cycle estimation. We would estimate the task and the stories, and they would be recorded, they would be retrospected, and they would be mitigated. This gave us, there was a very interesting data that I would like to share. So when I personally started with this project, initially the biggest problem that the management was facing was too much noise on infrastructure issues. If I remember it correctly, there were around like 100 tickets. There was a ticketing system, and there were like 100 tickets lying in the backlog for the teams to address, and nobody had a clue which ticket was solved and which was not. And following the best practices, we had an agile design for driving all these issues. And within a few months, with the automation that we were implementing, plus with the best practices like daily stand-ups, continuous retrospect, feedback mechanism, measuring what we are implementing, and remeasure and break down the task into smaller slices. All these good practices of agile were also adopted while building this infrastructure. And what result it gave us was that we brought our issue list, which was in hundreds. Almost every month there were like hundreds of issues that will come in, that was brought down to only a few, from 1 to 5 numbers. The reason behind that is, most of the times these issues were reported, people have no clue whether it was an infrastructure issue or it was a software or service issue. By splitting these issues into smaller slices, we were able to identify what were the issues which were strictly related to infrastructure and how these can be solved for a longer run. And by solving those problems, we were able to bring down the issues or upcoming problems on the infrastructure. And this also came in with poly-skilled cross-functional teams. As I mentioned in the beginning, this bank was a legacy system and there was a lot of silos. So there were a lot of experts in the bank. However, they all work in their own silos. If there was a database expert, he would only work in database. If there was a system expert, he would only work in the system. There was very less collaboration among them. Bringing in agile DevOps helped us build a kind of poly-skill cross-functional team. So we would do pairing and we would switch the pairs almost every week or every sprint. So what that gave us is that no single person becomes a single point of failure for any particular task. Every person in the team is aware of what's going on in the infrastructure or in the application, and we reduce the truck factor to 0, so that due to absence of a particular person, the whole team does not get impacted. So building poly-skilled cross-functional teams and agile DevOps helped us to mitigate or to address and be proactive towards solving these issues, and also help in their digital transformation on the digital journey. Now let's talk about the bank which was on cloud. And it's very interesting because we hardly hear about banks going on cloud, isn't it? There is a lot of security concern regarding that. And there are very few banks, in fact, which are hosted 100% on cloud. They would still have something on there, means they will have the data on premise, but they will have the applications on cloud. But this bank is 100% on cloud. So this bank started 2 years back. It was a startup which started developing these stories. So there was a lot of startup energy as well. However, Although things might seem that going on cloud from the very beginning would solve every issue, but that's not true. In cloud also poses a lot of challenges, especially for the banking sector if you are opting towards always on banking. The challenges were quite different in this case. The challenges that we faced on the on-premise bank were mitigated by going on cloud, but it added some additional challenges which we did not face in the on-premise bank. So what were these? Security was one of the biggest challenge, and we had to meet all the security demands. Now, when we are on premise, we are secure because we know that the data is co-located on our own systems and hardware. We have 100% ownership of from infrastructure to services to the system. So we don't get too scared about security. But the moment when something goes on cloud, the security becomes a big requirement because we don't have any control on the infrastructure. We have only access to the services. And in some cases, when we are using managed services, we have even less visibility on what's going on in the background because things just work, isn't it? And that is why for banks, security on cloud is very important to prove that their IP or intellectual property is protected. A bank cannot lose its data or have any compromise on their data. So IP protection is a big requirement of banks on cloud. And these banks were particularly located in Indonesia. So according to Indonesian regulator, the data for banks and financial services should stay within their country. So they had data localization compliance that they had to meet, and that data cannot be stored anywhere outside the country, not even in the form of logs or caches or monitoring. If they have customer data, it cannot leave the mainland. So IP protection was a big challenge. FinOps was also a challenge on the cloud because the moment we go on cloud, we get a lot of things on demand or out of the box, and scalability is one of such things. But with scale comes in the challenge of managing your budget. If your systems are scaling exponentially and if you don't have a control on your infrastructure spending, you will soon reach a situation where your infrastructure spending crosses your profit margin. And this has happened to all larger organizations who have faced challenges in managing or maintaining or controlling their budget, and they either over provision or they under provision. So FinOps is very important when you go on cloud so that you can attain the right performance without compromising on your budget. The other thing is high availability and disaster recovery. Now, you might think that why is HA and DR a problem in cloud? Because clouds come with high availability zones, etc. But that's where the challenge is. Very few of us would go and actually evaluate what kind of HA and DR scenario do they adopt to when they have these availability zones. Interestingly, it is not compulsory to meet all the exact HADR requirement that the regulator gives for a bank's availability zone. Let's say there can be one bank which has two availability zones with two data centers which are located 30 kilometers away from each other, which will meet all your requirements, all your regulators' requirements. However, there is another bank which has three availability zones, but those availability zones are technically on different buildings within the same data center premise. Now, by feature-wise, both have availability zone, but what is the disaster recovery or failover process for these availability zones or between these availability zones? And the second thing is, what if these availability zones are located in the same city? If the city comes under a disaster, what would that bank do? So these are some of the challenges which adds on when we go on cloud. And this is very important that all these information is validated with the cloud provider before the bank heads on to host their entire infrastructure on cloud. So HE and DR was a challenge for us because we had to meet the SLA of 99.99%. So we had to prove that the availability zones does meet with this criteria. And Interestingly, although it was a startup which was quite fresh and agile practices were enabled, but this was distributed across countries. There were people distributed across countries who were working together. And it was also one of the challenges because of the pandemic, which hit us last year. It was everybody went remote, and there was hardly any physical presence. So everybody would work from different countries, different time zones, and they had to, collaborate. And that was one of the challenges that we faced. However, it also brought us stronger when we were implementing these systems. Now let's look at the solutions that were implemented to mitigate these challenges. Like in the previous bank, we built always on platform as a service. In this bank, we built always on infrastructure as a service. Because we were on cloud, we had the possibility of automating the infrastructure right from scratch. Even the slightest thing on the infrastructure would be built with infrastructure as code. So we had that option, and we took it up, and we built always on infrastructure as service. And this was built with modular infrastructure as code. Now, what I mean by modular infrastructure as code is, many people misunderstand infrastructure as code with automation scripts. This is beyond automation scripts. This is about modularizing your infrastructure. For example, let's say you are building a microservice based application, and you are using a bunch of infrastructure resources. Let's say you have a microservices platform, you have a SQL engine, you have a NoSQL engine, you have load balancers. So you have a lot of components on the infrastructure that you are using. And let's say you have multiple teams building different microservices, but the backend stack is same. So for all of them, you have to provide this infrastructure as code. Now, there are two ways you can do it. You can write a single script, which will go and create all the infrastructure, and you can keep on copy pasting that for everything. So that has its own problem. Problem is that while you are duplicating your code, you are duplicating a lot of effort on the development, and also you are leaving very less window of enhancements. If a particular team needs certain feature, but the other team does not need it, you have less window to make sure that you meet all these demands. That is why modular infrastructure code is very important. Build module for every infrastructure resource, and then provision those modules on demand based on what that particular service or application needs. For instance, if you are building a bunch of SQL engine, let's say you are building Postgres, you have MySQL, you have Microsoft SQL, create one module for SQL and make sure that the implementation varies based on demand. If some teams needs Postgres, they would get Postgres. However, certain things remains common. For instance, they have high availability, they have encryption on disk, they have role-based access control. So those things remain same across the team. However, the engine might differ based on what kind of performance they need. And that is where modular infrastructure as code comes into picture. Again, zero downtime deployment was also implemented for this, and we had to implement it because this was an always on service. Because it was on cloud and security is the biggest concern on cloud, we had to implement a role-based access control system. So there was no window for anonymous or generic credential-based system that we use. Everything was role-based access control, and only if it is needed, that access would be given, especially for end users or for the developer or engineers. Access was always read only. They had to perform everything via automation scripts, and no direct access to infrastructure was given. It was only read only, no write access was given. Write access is always between service to service, and it was also segregated based on what role, what service is playing. We also enable auto scaling on demand, and this is scaling out. It is always recommended to follow horizontal scaling than vertical scaling, because that way you would have immutable infrastructure, and you could easily scale on demand whenever your traffic hits peak hour. And in order to achieve the HA and DR need that I mentioned earlier, we had regional multi-AZ clusters, and so that it meets the kind of SLA that we are trying to achieve. To attain all of these via infrastructure as code, we also implemented test-driven delivery of infrastructure. That means every module that we write, it will be tested unit-wise, as well as when it is being sent or executed as a provisioner, it will be tested as an integration point. So there were tests embedded in the infrastructure as code on a unit level as well as on the functional or the integration level. So the last but not the least, Agile DevOps also played a key role here. Like in the previous bank, Agile DevOps help us break the silos between the team by bringing them all on the same page and building poly skilled teams. Here, since although there were no silos, but the teams were distributed, so there were silos on a physical level, though mentally they were all part of the same organization, but they were different places. There was hardly any meetups. They would hardly meet each other, and to break that, Agile DevOps played a very important role, and the team had to could collaborate. And to be very honest, it posed a very less impact of the pandemic on us, because we had all the systems and the processes in place. We knew what to do when we were going remote. We didn't need to be physically present at the co-location place or work together. All of us would be connected, and because we knew that we had one goal, we had to follow these practices, and everybody were true to it. So this was the journey for these two banks, which helped us build the always on infrastructure for these banks. And there were some important lessons learned by me, which I would like to share with you while building this modern infrastructure for these two banks. And the lesson learned is that DevOps driven delivery practices and concepts are very important to understand. Just implementing the tools or putting some automation is not enough. It has to be understood why it is in place and are we meeting the result. If we are automating and if we are not able to meet let's say the 99.99% uptime, if our application still goes down when we are deploying, that means even automation is not helping us. So it is very important to put closer attention to the designs, and that is why the DevOps driven delivery is the key for any kind of smoother digital transformation. So what was learned in terms of process and tech? First thing is high availability using horizontal scaling and zero downtime deployment. Disaster recovery with multi-site backups and a DCDR model or multi-AZ model. Role-based access controlled identity management, not just user and password-based. It's role-based access control. You need to define what role a particular person is playing. Don't give all access to everybody. Just ensure that he only gets the access what he needs. Centralized logging, monitoring, and alerting to build fault tolerant systems and environment on demand with infrastructure as code, continuous integration and delivery, and cloud agnostic tech platform. And what we need on people and culture side is agile DevOps. That means estimate and record what you are going to play. Plan and measure. If something is too big, slice it out. Do not dwell on a task which continues forever. Break it into smaller chunks so that it can be looked into in parallel. Visibility and tracing. It is very important. Many people misunderstand visibility and tracing as micromanagement. That's not true. Don't look at it as a micromanagement. It is being more transparent to what we are doing on a day-to-day basis so that we can go back and also retrospect and see how we can improvise on what we have been working so far. And test-driven continuous delivery. Build, deploy, test, release. Very important. Continuous deployment is not enough. Continuous deployment will only show you that it can be deployed. But if The functionalities does not work, and if it cannot be delivered, that means it is of no use. So test driven continuous delivery, CDS, continuous delivery, is very important. You need to build it, you need to deploy and test, and only when all the functionalities are working, you can release it. Fail fast, fail early. It's okay to fail. It's okay to get the errors, multiple errors in the beginning, because the earlier we fail, the earlier we will be able to identify the issue and fix it in the longer term. So with that, I would like to conclude today's session. I hope that I could share some of the lessons learned for what it takes to build always on banking services on modern day infrastructure. Thank you, everyone.